All right, let's take a look at this problem. Suppose the interval from 1 to 3 is partitioned into n equals 4 subintervals. So the interval from 1 to 3 is our interval of interest for this particular problem. And we want to partition that into n equals 4 subintervals. And the first question is, what is the subinterval length, delta x? So this is equivalent to finding the width of each one of our rectangles. So we need to take this interval from 1 to 3 and divide it into 4 equal subintervals. So how do we do that? We first find the length of the interval, which is the right endpoint minus the left endpoint, and then we divide that by 4, because 4 is the number of subintervals. 3 minus 1 is 2, 2 over 4 is 1/2. So if we divide the interval from 1 to 3 into 4 equal rectangles, each rectangle will need to have a width of 1/2 unit. So we'll start at our left endpoint 1, add half a unit to that to get 1.5, add another half unit to get 2, add another half unit to get 2.5, and add another half unit to get 3. Now we have 4 equal subintervals on our main interval. Now we need to label each point on our interval x0, x1, x2, x3, and x4. x0 will always be the left endpoint of our interval, and then x sub 4 in this case will be the right endpoint of our interval. And then 1.5 will be x sub 1, 2 will be x sub 2, and 2.5 will be x sub 3. And the next question is, which of these points will be used for the left Riemann sum, the right Riemann sum, and the midpoint Riemann sum? F of x sub 0 will be the height of our first rectangle, so f of 1. F of 1.5 will be the height of our second rectangle. F of 2 will be the height of our third rectangle, and f of 2.5 will be the height of our fourth rectangle for this left Riemann sum. Notice for the left Riemann sum, we used the leftmost endpoint and then followed through with the successive endpoints after that until we reached 4 of them. Notice that we didn't use the rightmost endpoint for our left Riemann sum. For the left Riemann sum, we started with the leftmost endpoint of our interval. And for the right Riemann sum, we'll start with the rightmost endpoint of our interval. That means for the right Riemann sum, the x values that we use to find the heights of our rectangles will be 3, 2.5, 2, and 1.5. And then the x values that we'll use to find the height of our rectangles for a midpoint Riemann sum will be the midpoints of each one of these subintervals. So our first x value for the midpoint Riemann sum will be halfway between 1 and 1.5, 1.25. And then halfway between 1.5 and 2 is 1.75. And then halfway between 2 and 2.5 is 2.25. And halfway between 2.5 and 3 is 2.75. So the width of each rectangle, or the delta x, is 1/2. And then for the left, right, and midpoint sums, we would use the respective x values that we listed below to find the heights of each one of those rectangles. And then if we were given a function, we could use that information to find our Riemann sums. In this example, we're asked to use the figure to calculate the left and right Riemann sums on the given interval for the given value of n. And here we have the function f of x equals x plus 1 on the interval from 1 to 6. And we need to divide this interval into 5 subintervals. So we know the width of each rectangle, or our delta x, is equal to the total length of the interval, which is 6 minus 1, and we need to divide that into 5 subintervals. So that means the width of each rectangle will be 1 unit. So here I've set up our rectangles for our left Riemann sum. The height of the first rectangle will be f of 1. The height of the second rectangle will be f of 2. The third, f of 3. The fourth, f of 4. And the fifth, f of 5. So our left Riemann sum will be delta x multiplied by the sum of each of these function values. And that will give us the sum of all the areas of our rectangles. To get the function values, plug each of the x values into the function. So f of 1 is 2, f of 2 is 3, f of 3 is 4, and so on. So our left Riemann sum is 20. Now let's do the same thing for the right. Notice that I've shifted all of our rectangles so that the right side of the rectangle now intersects the graph of our function. The width of each rectangle is still 1, so we'll have 1 times the sum. The height of the first rectangle is the function evaluated at 2. The height of the second rectangle is the function evaluated at 3. The height of the third rectangle is f of 4, and so on. Evaluating the right Riemann sum gives us 25. Now it's important to note that neither of these values, the left or the right sum, is the exact area underneath the graph of this function. The left Riemann sum is an underestimate, and the right is an overestimate, because we included this portion in the area of the rectangles that did not fall under our curve. That's what makes the right an overestimate in this case. The left was an underestimate because we didn't include all of the area under the curve. And in general, if our function is increasing over our interval, the left sum will always underestimate the actual value of the area under the curve. If the function is decreasing, the left sum will be an overestimate. Likewise, the right sum, if our function is increasing, will overestimate the area. And if our function is decreasing, the right sum will underestimate it.